Hi students, our study today is to study the table of sign of a function when the function is positive, when negative, when is zero. We're going to start by the property if you have an equation of first degree of the form ax plus b. So if you want to solve for x when f of x is positive, for x when f of x is negative, so what do we do? First of all, suppose f of x equal to 0, so ax plus b equal to 0. So here x equal minus b over a. F of x is positive, it means ax plus b is positive. It means x bigger than minus b over a if a is positive, if coefficient of x is positive. But if coefficient of x is not negative, so this bigger will be less. Okay, so that's why we're going, and similarly for f of x less than 0, you can read it by yourself. So we're going to summarize everything here in the table of sign. First of all, what's the table of sign? So we take the roots. If we equate it as we said, it's minus b over a. Okay, so here we have minus b over a. We do the table x starting from minus infinity and ending at plus infinity. We look at coefficient of x. If the coefficient of x here, as you can see, is positive, so we say opposite sign of a, then same sign of a. Why? Because if I want f of x to be positive, I'm taking the condition when a is positive. So if a is positive, so when x is bigger than minus b over a. So, and since a is positive, so here a plus, here will be minus, and similarly, it will be just the opposite if negative. So from now and on, if ax plus b, you want to find the root, first of all, minus b over a, you look at a. If a is positive, you start by minus, then plus. If a is negative, you start by the plus, then after minus. We will understand this by taking example. So it will be very simple example here, the first one. Here I'm talking about, I want to study the sign. I know you can do it directly, 2x bigger than 4, x bigger than 2, and that's it. But I want to do it using table of sign. First of all, I equate it to 0. So if you equated the 0 here, you're going to get a root 2x equal to 4. X is 4 over 2. So we put 2. This is x. This is the line here. We put these two lines from minus infinity till plus infinity, right? And then I write after the function, which is 2x minus 4. So the root here is 2. F of x is 0 if x is 2. And if it's, you look at coefficient of x here is 2, which is positive. So opposite sign, same sign. So minus, then what? Plus. What I want is positive. So positive, it must be here. So here it means from 2 till infinity. Because I want it bigger, I don't have equal. So from 2 till infinity. So open interval 2 till infinity, or I can write it from 2 open parenthesis then infinity. It means the interval. And graphically, this is the root, which is 2. To the right of the 2, it must be up. So here the function is positive. And to the left of the 2, here the function y, which is f of x, must be negative. This is the graphical representation. Let us not take more problems. Suppose I have this expression. First of all, I want it to be bigger or equal to 0. So I want to search for the root of every one. So for the first one here, the root, if you equate it to 0, minus 2x equal to 4, x will be minus 2. For the second one here, it will be minus 3, the root, if you equate it to 0, as you know. Here, if you equate it to 0, the root will be 2. So I put minus 3 from increasing order, then minus 2, then 2. So I take the first factor, minus 2x minus 4. The root here for this one is minus 2. So I put here is 0. I look at coefficient of x. Coefficient of x here is minus 2. So opposite sign, plus, then plus. Then when you reach the 0, you switch. Switching, it means I put minus, then minus. For the second one, I have x plus 3, so the root is x minus the minus 3. So coefficient of x here is 1, which is positive, opposite minus. When you reach the 0, you put plus, then plus, then plus. And the last one, you have minus x plus 2, the root is minus 2. The root here, sorry, it's 2. So minus x plus 2 is 0, minus x equal minus 2, so x is 2. Coefficient of x is negative, so opposite sign, always opposite, then same as we said in the property, then here positive, then negative. Now, this whole expression is 0, is one of the root is 0. And if x is minus 2, here this will be 0 times any number is 0, and so on. So here I put zeros for the three roots. Because if the function is, if you take in the function x is minus 3 or minus 2 or 2 and you replace it, you have all 0. Now I have a product, plus times a plus, it's minus. Triple plus product is a plus. I have minus, double minus is a plus. What I want bigger or equal. This is bigger or equal, this is bigger or equal. So bigger or equal, so from here till here, and from 2 and up. So here if I want to write it, because here I have equal to 0, so I close at minus 3. So from minus 3 till minus 2, union, it means or, from 2, sorry, I close it here because it is both equal. So from 2, close it because I want the boundary, so I can take these zeros from 2 till infinity. Now graphically, infinity always open, but here at minus 2, 2 and minus 3, always I close it because I have equal. Now, if I want to graph, first of all, I have the root at minus 3 here. I have another root at minus 2, and then I have a root at 2. Now, before minus 3, the curve must be down. So the elevation must be down, for example, here, and you can graph whatever you want, no need to be accurate. Then from minus 3 till minus 2, it goes up, then it goes, sorry, to 2, because here it must be positive above the x-axis. Then from minus 2 till 2, it must go down somewhere. Then 2, it will be 0. Then after 2, it goes up, the elevation. F of x, it means the elevation. So it must have that 4, okay? And passing by the root minus 3, minus 2, and 2. No need to get an accurate curve. If you want an accurate curve, you can go to Geogebra here. For example, let me put it g of x equal minus 2x minus 4 into x plus 3 into minus x plus 2. If you graph it, as you can see here, it will be accurate. What concerns me, minus 3, minus 2, 2 is the roots coming from down, because here, as you can see, negative, then the root at minus 3, then going up, positive between minus 3 and minus 2, here between minus 3, then from minus 2 till 2, it goes down till 2, then after 2, it's up above, which is positive. Let us take more examples. Here I have 4 factors. I want it to be less than 0. So let me start first of all by finding the roots. Here you have the root 0. Here you have the root 1. Here you have the root minus 2 if you equate it to 0. And here if you equate it to 0, you have 4. So from the least one minus 2, then 0, then 1, then 4. I start by minus 3x. The root of minus 3x is 0. If you equate it to 0, it's 0. You look at coefficient of x, it's negative. You start by opposite, plus, plus, minus, minus, minus. X minus 1, the root is 1. Coefficient of x is positive, so opposite, minus, 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 positive, positive. The third one, x plus 2, the root is minus 2. Coefficient of x is positive, so opposite, then all plus. Minus 2x plus 8, the root is 4. So coefficient of x is negative, so plus, 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 plus. When you reach 0, you switch. So I have f of x, this whole expression is 0, is one of the factors is 0. So it's either here 0 or here I put 0 on all function f of x. It's a product. If you multiply these, minus times minus is a plus. Here minus, here plus, here minus, here plus. So what I want it less than 0, but I don't have equal, so all open. Less than 0, so here minus, so it's from -2 till 0. Here, as you can see, it's also minus. I have from 1 till 4. So x belong open. I don't close it because I don't have equal. From -2 till 0. Union from 1 till 4. Graphically, if you want it to be accurate, you can go to Geogebra. For me, I want to graph it here from -2 till 0. These are the root. You have 1 and you have what? 4. So before -2, it's coming from up. Between -2 and 0, between these two roots, it's negative. It goes down negative. Then from 0 till 1, it must be positive elevation. And then from 1 till 4, here 4, it must be down. Then after 4, it must go up. You can check using Geogebra if you want. Okay? Now I will start examples when you have the denominator and what differs. Here, first of all, I find the roots. You have -2 of numerator. Here you have 1. Here you have 3x equated to 0. You have 0. And the last one you have 4. You put the smallest -2. Then, sorry, here it's 1. Yes, as I said 1. So 0, 1, and 4. So the first root for 2x plus 4 is -2. Same. Coefficient of x positive. Minus opposite, then same. For the second one, minus x plus 1, the root is 1. So you start plus because coefficient of x is negative. Then minus. The third one, 3x, coefficient of x is also positive, opposite. And for minus x plus 4, the root is 4. And coefficient of x is negative. So plus, 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 minus. Now, the product here is a plus. Here is minus. Here it's a plus. Here it's minus. And here it's plus. You all know if numerator is 0, 0 over any number is 0. So if you replace x by -2 or x is 1, 0 over a number is 0. So all the roots that of numerator will be 0. But if you want to divide a number not 0, suppose a is not 0, over 0, this is called undefined, which is a plus or minus infinity. In math, we say we have a vertical asymptote. So the curve will come near the point and will not touch it. So I will tell you graphically what does it mean when we start graphing in a while. So here, the value at 0 to say, I cannot divide by 0. So we put this arrow here. This is called undefined. And at 4 also, because you're going to, if you take x to be 4, so you're going to get a number times a number in the numerator, a number not 0 over 0, which is impossible, undefined. So we say here I have undefined. So always the values, the roots or the 0 that make denominator 0 are undefined. And if numerator is 0, you put zeros on f of x. What I want it less or equal to 0. So here and here. So I have it from here till here. So if I want to write it, I have equal. So I must take the boundaries. So here I close it at -2. But at 4, because, but at 0 here, because 0 is impossible, I don't close it. Always here it is what? Because it's impossible. Then I have it from 1, because 1 can be 0 because it's a root in the numerator. Then till where? Till 4. But 4, because it's denominator, it's impossible, so I do it open. So if I want to graph now that first of all I put the root minus 2. You have 0. 0 is impossible, so we do it like this, a dot line to say it's a this is in math later on in calculus called a vertical asymptote. The curve will not cut that line. It will come near, but it will not touch it. Here at 1 it's a root, but at 4 is also it is a vertical asymptote, which is impossible. The curve cannot cut. So what do we mean by vertical asymptote? How we're going to graph it, you're going to see in a while. So first of all, the curve is coming from up. You have zeros at, suppose coming from up, you have 0 at minus 2. Then it goes down, but it will not cut 0. It will come near, but it will not touch it. It will come near. This is called vertical asymptote. So it will come near, it goes down. As it goes down, it will come near the line, but it will not touch it. So it will become near epsilon of distance. It will become near, this is called asymptote. It cannot cut 0 because we cannot divide by 0. So we take it down, it will become near the vertical line, but it will not touch it. Now it's coming from up. To the right of 0 is coming from up, also vertical asymptote. So up vertical asymptote, you have root at 1. So it will become coming from as an asymptote, then touching 1, then going where? The root at 1, then it continue down, and it will become near the 4, but it will not touch it. So this is called the vertical asymptote. As it goes up, it will come near 0 here, but it will not cut 0, nor here it will cut 4. And after 4, it comes from up, vertical asymptote, same thing, and keep up. It will not go down. So I don't have a root. It will not cut or go down. So you can have here a vertical asymptote, and it goes always up in the curve, always up. This is called here, later on you're going to notice here we discuss what's called horizontal asymptote, but it doesn't matter. The most important, you must not take it down. You can put it like this and do it as horizontal, or you can take it up, because I'm not graphing a accurate curve. And what I want less or equal to 0. So graphically, this part that I want here, the dot part, okay. And here, so these are the two solutions that I have wrote here. Let us take more examples. Here, also I have numerator and denominator. If I do the roots here, it's minus 2. Here I have the 3. Down I have a vertical asymptote, which is 0, which is undefined. And here I have the 7/3. So I put in increasing order. So I start. The first root here is minus 2. So opposite coefficient of x plus, then minus, 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 minus. The second one, it's a 3. Here, opposite sign, so minus, 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 then a plus. Now impossible at which value? At 0. Coefficient is positive, negative, so plus, plus, then minus, minus, minus. And the last one, you have the root here. Coefficient of x is positive, so minus, 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 then a plus, then a plus. So if I put this sign here, it's positive. Here it's negative, positive, negative, and positive. Now it can be 0 at minus 2 and at 3, but it's impossible at denominator because we cannot divide. So we say here we have a vertical asymptote. Okay. What I want is less or equal to 0 here and here. So I say x belong, it can be closed at minus 2. Open at 7/3 because it's the denominator, it's a vertical asymptote, impossible to be closed because you cannot divide by 0. Sorry, not 7/3. I need to change it here. Sorry, it's from minus 2 till 0. Okay, from minus 2 till 0. I close it at minus 2 because I have equal to 0. Then I close at 0. Sorry, as I said, it's open. So then union I have here also impossible at 7/3 open, always at vertical asymptote I open, then till where? Till 3, and the 3 is closed here, as you can see, because I can close it. So if I want to graph it, here you have -2 is a root first of all, 0 is a vertical asymptote, the curve cannot cut that line. Then I have at 7/3, 7/3 it's near 3, the 2 point, for example, if you want to divide 7 by 3, it's 2.1333. You can put it here, and the 3, and this is a vertical asymptote, so the curve cannot cut the 7/3, and you have the last root here at 3. So how do I graph it? So from -infinity till -2, it's above. Okay, it's positive. Okay, then it cut at -2, this is -2, then it goes to 0, negative, but vertical asymptote. It will go down negative always, it will become near the line, but it will not touch it. And then from 0 till 7, then it comes from up positive, but vertical to 0. So here vertical to 0, okay, and all is up, it will not go down, then it goes somewhere down, you have a minimum somewhere, then it goes vertical asymptote to 7/3. It will become near, but it will not touch it. Then from 7/3 it's down, you can see here it's minus, from down it passes, sorry, to 3, and then it goes where? Up, but here it will become near the line, but it will not touch it. Okay, what I want it less or equal to 0, so this part of the curve and that part of the curve. To finish, let us take the last example. Suppose I want to solve this one. You take the 2 to the other side, same denominator, you have this one. So here you have two factors, one in numerator, one in denominator. Here you have the root is 4. So coefficient of x positive, positive, then negative. The second one, it's a 3. So here it is, the root is a 3, so minus, positive, positive. So it's a minus, plus, minus. As you can see here, the 4, the root here, 4 is up in numerator, it can be 0. And here it's down the 3, it's in denominator, so it's vertical asymptote. What I want less than 0. Less than 0 is here. So open, because I don't have equal, always open at infinity, but at, and the 3 is also open. Why? Because it's a vertical asymptote. Even if I have equal here, I must put the same union. I have here the common part negative, here the 0. So I close it at 4, because this is not a vertical asymptote. This is root in the denominator, numerator, till where? Till infinity. Okay. So here, if I want to put, you have at 3 a vertical asymptote, and you have at 4 is a root, which is 0. So it's coming from down, anywhere down, okay, and always it's down. As you can see here, I have a vertical asymptote here, always down. So it cannot goes up, it cannot cut the x-axis, so always down. You can have it like this, a horizontal asymptote, then going down like this, a vertical asymptote. Then you have coming from up, vertical asymptote, passing by the point 4, okay, and then it continue where the curve will continue down. What I want here also less than 0, so this part and the part here without the root till down. Hope that you have enjoyed and you understood the table of sine in first degree. I'm going to see you in the table of sine second degree. Thank you for listening.